In the content for this section, there was a toolbox that gave you steps in order to find the equation of the inverse. I'm going to go through a couple of examples using that now. We're going to start with the equation of a line, f at x equals 2x plus 5. I know it's a line because this kind of looks like y equals mx plus b. I'm going to write it using y instead of function notation because f at x is just another way of saying y because y is a function of x. We do something to x to get y. The reason why I get rid of the function notation and put in the y is that the first step in finding the equation of the inverse is to switch your x and y because invert literally means switch the places of your variable. So instead of y equals 2x plus 5, I have x equals 2y plus 5. But there's a problem with this from a convention point of view. Convention says that our equations are always written as y equals. So I'm going to do some manipulation of this equation in order to get the y by itself. I'll bring the 5 over to the other side and subtract it. Then I'm going to divide by 2. So now that I have y by itself, this is the equation of the inverse. But I want to mirror what they gave me. They gave me f at x notation, so I'm going to use f at x notation back. And this is not an exponent -1. This is a short form or math language for inverse. So f inverse of x equals x minus 5 over 2. Now, I know the inverse will be a function because the inverse of any line other than a horizontal line will always be a function. I'm going to just go through quickly what would happen so that you can see why. 2x plus 5, that's a line that has a y-intercept of 5 and a slope of 2 over 1. So I'm going to get something that looks like that if it were straight. And this is just a sketch for illustration, so I'm not too worried about using all of the conventions. Inverse means to switch the point. This point is at 0, 5, so it's going to become 5, 0. This point, I'm not quite sure where it is, but it's at negative something, and I could solve it. I think it's going to be negative 2.5. I'm not 100% sure, but it's negative something and 0, so that's going to be 0 and negative something. So that's what my inverse would look like. The inverse is always a reflection or a mirror image around the 45-degree angle line or the line where y equals x. These would both pass the vertical line test, so this is a function. And again, the only time the inverse of a line is not a function is if you start with a horizontal line, it's a function, but when I invert it, I get a vertical line. And a vertical line fails the vertical line test because if I put a line right here, then it's going to touch more than once. And again, I can start to see my reflection or my symmetry. We're going to repeat that process, but now we're working with a quadratic equation, which I know is a parabola, and I know that because it has an x squared. So y equals 2x squared minus 7. Haven't done any work in that step, but replace the function notation with y. Now I'm going to switch my x and y, and now I'm going to start to solve for y. I bring the 7 over and add it. I divide by the 2, and now the last thing I need to undo or get rid of is a square. The inverse operation, or something that solves or gets rid of a square, is a square root. So I'm going to square root this side. And a lot of times we throw the plus minus because numbers have 2 square roots, the positive and the negative in front of that. Now, again, I know automatically that this is not a function. Oh, and I can't forget to state it with my function notation. F inverse of x is the positive or negative square root of x plus 7 over 2. I know it's not a function. The reason why I know it's not a function is this is a parabola. I'm going to go through it though just to make sure that you see why. So 2x squared minus 7 looks something like that. The vertex is at 0, negative 7. It opens up because that's a positive, and it opens up fairly quickly because the pattern has been doubled. So I'm going to invert this point right here. 0, negative 7 becomes negative 7, 0. These 2 points here, when I flip them, one will end up there, that's this point. One will end up there, that's that point. And again, if I took my time and really did a good job, the symmetry would show up a little bit better. But as soon as I invert the parabola, I get this sideways parabola or U-shape, which will always fail the vertical line test at a whole bunch of points and not be a function.